Lewis uses a 20 centimeter long wrench to tighten a nut, turning it clockwise. The wrench handle is tilted 30 degrees above the horizontal, and the Lewis pulls straight down on the end with a force of 100 Newton. How much torque does Lewis exert on the nut? Okay. Here, if you see this one, this is the wrench, and then it is making an angle of 30 degrees above the horizontal. So this is the angle. Okay, this angle is 30 degrees. Okay, but we require the other angle, this angle, remaining angle. Okay, I will show you. This is what is required for us. Okay. So this angle we get, this is 60, 90 minus 30, 91, this is the 5. That is equal to 90 minus 30. That is equal to 60 degrees. Okay. Now, R bar is equal to 20 centimeters. That is equal to 20 divided by 100. That is equal to 0.2 meters. And then F is given as 100 newtons. And then phi is equal to 60 degrees. And then torque tau is equal to R cross F bar. Therefore, this is equal to R bar F bar sine phi. Okay, and then here he is saying that clockwise direction. I told you clockwise direction is negative. Therefore, torque is negative. Therefore, torque is equal to minus 0.2 meters times 100 newtons times sine 60 degrees. So this gives negative, this is 0.2 times 100 times 0.8660 gives negative 17 point, okay, 32 Newton meter. Okay. This is the answer for this question. It's a simple question. You have to visualize the angle for the torque. Okay. Because the angle should be between the point of application of force and the radial line, between the R and F bar. This phi should be R and F bar. Okay. This is the 20 centimeters length. Okay. So this should be the angle. He gave this angle. You have to take the other angle. Okay. Thank you. Bye-bye.